For this problem, we have a 3.5 microcoulomb charge located at the origin, so we'll call that Q1. And then we have a minus 4.2 microcoulomb charge located out here. At a distance of 68 centimeters away, so 0.68, and then we want to know at a point up here along the y-axis, that's 48 centimeters away from Q1. We want to know what the electric field is at this location. Magnitude and direction of the electric field at that location. Okay, so well, let's see. First of all, the electric field due to charge 1 is going to point upward, right, vertically upward, because it's repulsive. And the electric field due to charge 2 is going to be pointing in the direction of charge 2, like that. Now we're going to need this distance here. Let's see, the Pythagorean theorem tells me that this distance is 0.832 meters. This angle theta here is just a right triangle, so theta is the inverse tangent of opposite over adjacent, which is 35.2 degrees, and that means that that angle here is also theta. Okay? Okay, so let's find the magnitudes of E1 and E2, and then we'll combine our vectors. So E1 is using our formula for the electric field of a point charge. That works out to 137,000 volts per meter, or newtons per coulomb if you prefer. And then E2 and I'm just finding the magnitude here, so I'm just going to use a positive value for the charge. Oops, this should be 0.832, shouldn't it? That works out to be 54,600 volts per meter. Okay, so I've got the magnitude and direction for the two vectors I need to combine. So to combine these vectors, I've got to split them up into x and y components. So the x component of E1 is 0. The y component of E1 is, let's see, well actually, let me arrange it like this. This will be the x component of E2. We'll do the y component of E1 over here. The y component of E1 is just the magnitude of the vector. It's 137,000. Okay, now for the x component of E2. So E2 points down like this, right? Here's our E2. Okay, so it's going to make an angle of 35.2 below the horizontal. So this is going to be E2x, and this is going to be E2y. So E2x is 54,600 times cosine of 35.2, which works out to be 44,600. And then the y component is going to be minus, right, because it points down. Our sign convention for this is going to be the Cartesian sign convention. So since the y direction points down here, that's going to be negative. Negative 54,600 sine 35.2, which is negative 31,500. So if I add up the x components, they add up to 44,600. If I add up the y components, they add up to 105,500. And now I need to reconstruct my final vector. So the x component of the final vector is positive 44,600. The y component is positive 105,500. So there's going to be our resultant vector with some angle alpha here. or resultant E, I guess. Okay, so the magnitude of the resultant can be found with the Pythagorean theorem. And that's 110,000 volts per meter, rounding off to 2 sig figs. And then our angle alpha here, alpha is inverse tangent of opposite over adjacent, so that's 105.5 over 44.6, which is 67 degrees. And it's above, this is the plus x-axis, so it's above the plus x-axis. Okay, so there's our final answer there.